When we think of the Indian monsoon, a powerful image often springs to mind. We picture the dramatic June rains, the torrential downpours that flood streets and transform landscapes in what seems like an instant. This is the South-West Monsoon, the dominant force that shapes India's climate, dictates its agricultural cycles, and influences the lives of millions. But the monsoon is far more than just a single event. It's a complete and intricate cycle, a continuous process of atmospheric change. It's a seasonal reversal of winds, a fascinating dance of air currents that creates two distinct rainy seasons, each with its own unique characteristics and impact. Often overlooked, the lesser-known North-East Monsoon, also referred to as the Retreating Monsoon, plays a crucial role in this cycle. This phase arrives from October to December, marking a shift in weather patterns across the subcontinent. It mainly impacts the southeastern coast of India, bringing much-needed rainfall to regions that rely on it. While often quieter and less dramatic than its southwestern counterpart, it's vitally important. It plays a key role in ending North India's intense heat, providing a welcome respite, and bringing crucial rain to Tamil Nadu, sustaining its agriculture and water resources. This dual system, the interplay between the southwest and northeast monsoons, is absolutely key to understanding the complexities of India's climate and its regional variations. The transition between these two phases is gradual, a delicate dance as the powerful southwest monsoon slowly withdraws its influence. And as it does, the northeast monsoon gradually takes over, reshaping weather patterns and bringing its own unique brand of rainfall to specific regions. For students and exam aspirants, recognizing the monsoon as a complete cycle with its distinct phases and regional impacts is absolutely essential for a comprehensive understanding of Indian geography. The October-December rains are not just an afterthought or a minor footnote in the grand narrative of the Indian monsoon. They're a lifeline, a critical source of water and sustenance for southern India, particularly for the state of Tamil Nadu and its agricultural communities. The North-East Monsoon is triggered by the shifting Intertropical Convergence Zone, or ITCZ. In summer, the ITCZ moves north, drawing moist winds from the ocean. This is the South-West Monsoon. As the land cools after September, high pressure builds over northern India and the ITCZ shifts south. This reversal causes winds to blow from the northeast, from land to sea. These northeast monsoon winds start off dry, bringing clear skies and cooler temperatures to most of India. The Coriolis effect steers them across the country, reinforcing their direction. This organized retreat is a direct response to changing pressure and temperature. Understanding this shift explains why southern India gets its November rains. The northeast monsoon winds begin dry, crossing the subcontinent from Asia. But as they sweep over the warm Bay of Bengal, they absorb moisture. This transformation is crucial. Without the bay, these winds would bring no rain. When the moist winds hit the eastern Ghats, they rise, cool, and release rain on the coastal plains of Tamil Nadu and southern Andhra Pradesh. This orographic lift explains why the Coromandel coast gets its main rainfall in winter. The Bay of Bengal turns a dry wind into a rainbringer for the southeast. The North-East Monsoon, a period eagerly awaited by the people of Tamil Nadu, is the state's main rainy season. It's a time when the parched lands begin to rejuvenate and the rivers start to flow once more. This vital monsoon season is responsible for providing nearly half of Tamil Nadu's total annual rainfall, playing a crucial role in the region's water resources. Unlike most of India, which eagerly anticipates the arrival of the South-West Monsoon, Tamil Nadu has a unique dependence, as it primarily relies on the North-East Monsoon, in contrast to the South-West Monsoon that brings rain to much of the country. Tamil Nadu depends significantly on these retreating winds, which gather moisture as they traverse the Bay of Bengal, to replenish the reservoirs, vital for drinking water and irrigation, and to sustain the agricultural practices that feed the state. Densely populated cities like Chennai heavily rely on this seasonal rainfall to ensure water security for its millions of residents. But this season, while life-giving, also brings a significant element of danger. October and November, while bringing much-needed rain, are also the peak months for the formation and intensification of cyclones in the Bay of Bengal, posing a grave threat to the coastal regions. The consistently warm sea surface temperatures and inherent atmospheric instability act as fuel, creating conditions ripe for the development of powerful storms that often make landfall, striking Tamil Nadu and Andhra Pradesh with devastating force, causing widespread floods, infrastructure damage, and significant displacement of communities. Devastating cyclones such as Gaja and Nivar in recent memory have starkly demonstrated the destructive side of this monsoon, leaving behind a trail of destruction and hardship. Therefore, robust disaster management strategies and effective early warning systems are absolutely critical during this period to mitigate the potential impact. The North-East Monsoon, therefore, presents a dual nature. It is both a provider of essential water resources, but also a significant threat to the southeast coast, demanding constant vigilance and preparedness. The North-East Monsoon is vital for agriculture in southern India, especially for Rabi crops like rice, millets, and pulses. These rains recharge groundwater, fill rivers and reservoirs, and support hydropower and drinking water supplies. Water availability from this monsoon sustains industries and urban life. State governments invest in water conservation to capture every drop. But cyclones and floods can cause huge economic losses, straining resources and requiring major recovery efforts. The monsoon's impact is a double-edged sword, essential for prosperity, but potentially disruptive. Managing its benefits and risks is a key challenge for the region. The Southwest and Northeast monsoons, while both vital to the Indian climate, differ significantly. These differences manifest in their direction of flow, geographical origin, and overall impact on the country's weather patterns. The Southwest Monsoon is characterized by its journey, bringing moist ocean winds laden with humidity. This phenomenon occurs annually from June to September, marking a crucial period for agriculture. The Southwest Monsoon is responsible for drenching most of India, providing essential water resources. In contrast, the Northeast Monsoon, also known as the Winter Monsoon, typically spans from October to December, bringing a different set of weather conditions. The Northeast Monsoon starts as dry continental winds originating from the landmass of northern India, only picking up significant moisture as it traverses over the warm waters of the Bay of Bengal. Consequently, it mainly affects the southeast coastal regions of India, particularly Tamil Nadu. The Southwest Monsoon is characterized by its long duration and widespread geographical coverage across the country, whereas the Northeast Monsoon is shorter in duration and more regional in its impact, focusing on the southeastern parts. Southwest rains are generally steady and orographic, meaning they are influenced by the topography of the land, especially the western Ghats. Northeast rains, on the other hand, are often more variable and less predictable in their intensity and distribution, and are often linked to the formation and movement of cyclones in the Bay of Bengal. Understanding these fundamental differences between the two monsoons is crucial for a variety of reasons, particularly for geography students and those aspiring to clear competitive examinations related to environmental science and meteorology. The science behind the November rains in Tamil Nadu, involving the shift of the Intertropical Convergence Zone, ITCZ, the reversal of wind patterns, and the crucial role played by the Bay of Bengal, collectively completes the comprehensive picture of India's complex and fascinating monsoon system. Together, these two distinct monsoon systems intricately shape the overall climate, agricultural practices, and the daily lives of millions of people across the diverse landscapes of the Indian subcontinent.